Welcome to the video for Unit 2, Lesson 1. This is the first video of our new unit, and in this lesson we're going to be looking at some angle pairs that are created when we have two parallel lines cut by a transversal. So before we head into that, let's make sure that we have an understanding of what parallel lines are. So you guys probably know a definition of parallel lines where we have two lines that never meet, but we're going to formalize this a little bit more where we are addressing the fact that they are always equal distances apart. Now what that means is if I have that these two lines here on the left are parallel, I know that if I take a ruler and I measure the distance from here to here, I know that that's going to be the same as the distance from here to here, from here to here, no matter where I decide to measure it. If one of the distances is 3 inches, then I know all of the other distances have to be 3 inches as well, no matter where I measure from. Now the same thing holds, you can have more than two parallel lines, like in this example here. Now if these two lines are parallel, I know that if I measure the distance from any point, they have to be the same, and then separately, these distances would have to be congruent to one another as well. Now getting into some notation, we have to get used to seeing this symbol here for parallel. So this reads as A is parallel to B, and you might also see these arrows in your diagram. Now these arrows are a signification of the fact that we have parallel lines. So even if you don't see something written like this, pretend that wasn't there. If you see these arrows anywhere but on the edges of your lines, like these arrows are separate from the ones that you see here. So make sure you're looking at these arrows here. That is an indication that we have those parallel lines. Now we differentiate with that as well. You can see that here I have two arrows. Now in this example there are only one arrow on each of our lines, so the number of arrows can help us figure out which lines are actually parallel to each other. So this one here reads that J is parallel to K is parallel to L, so make sure that as we're going through these that you guys are pausing and filling in the necessary stuff in your notes. Now, the next definition that we have to talk about is a transversal. So a transversal is a line that intersects two or more lines. So on the left here, you'll see two parallel lines without a transversal, and just to get in the habit of some notation, you might see arrows that look like that. Now parallel lines with the transversal, we are just adding a line that way. That line can be, it can go in any direction. So you might have a transversal that looks like this, you might have a transversal that looks like this, you might have a transversal that goes straight down. So just be aware of the different types of transversals that you might have. Now, the first angle pair we're going to talk about are alternate interior angles. Now, less formally, this alternate interior angles is the formal name that we use. So the less formal name that we're going to use are the Z angles. Now, the Z angles are going to be something that helps you identify your alternate interior angles. So whenever you have parallel lines cut by a transversal, what you guys can actually do with the highlighter or a colored pen is literally highlight your letters, like highlight the Z. So let's say we have line L and line M here. What you can actually do is go on line L, highlight your transversal, then go on line M, and then your alternate interior angles are going to be on the inner corners of your Z. So right now, you guys have to fill in alternate interior angle pairs, so I know that angle 3 and angle 6 are alternate interior pairs, and then your Z can go backwards as well. Now your Z's can look funny, and that is totally fine. However, we're going to go backwards here. So if we make a backwards looking Z and we look at the inner corners of our Z, we know that angle 4 and angle 5 are alternate interior angle pairs as well. The next angle pair we're going to talk about is alternate exterior angles. So again, we're going to use our Z's. However, instead of looking at the inner corners, what we're going to do is look at the outer portions. So this one might be a little bit confusing, so do your best to follow along. But what we do is instead of looking at our inner corner, like before we looked at angle 3 over here, we're not going to look at angle 3 anymore. What we're going to look at is the outside. So angle 2 and angle 7 are alternate exterior angles. Now you can also use the name to help you figure it out, right? They're alternating, which means they're on the opposite side. Our transversal is here. So our alternate exterior angles, first condition, they need to be on opposite sides of the transversal. Second condition is they need to be on the outside. So the inside of our diagram is in here, right? So we know that if we wanted alternate exterior angles, they cannot be angles 3, 4, 5, or 6. So we know that it has to be on the outside and they have to be on opposite sides of the transversal. So if this Z doesn't really help you here, what you can do is just use the name to help you figure it out. So going back to here, we said angles 2 and 7 are alternate exterior pairs, and then if you draw your backwards Z, you'll look at angles 8 and angles 1. So angle 1 and angle 8 are the other pair of alternate exterior angles. All right, next angle pair are corresponding angles. So these we call F angles, and there are a lot of different ones here. We're just going to go over two of them. So the first thing you want to do, you highlight your transversal, and then you are making an F shape. Now what you need to do is look at these two angles here. So angles 4 and angle 8 are corresponding angle pairs. What you can also do is look at, like we looked at the corner. I don't know how you want to explain like which part of the F we looked at, but you can also look at the opposite side as well. So I know that from this image that I just drew, angle 6 and angle 2 are also corresponding angles. Now this might be a separate F here, so if you wanted to, your F's can look upside down. So I'm going to do that on this side in blue. So if we drew our F's upside down like this, then you can see that we have angle 6 and angle 2. So that this kind of corresponds with this image over here. So again, your shapes, it doesn't have to be a perfect F, but it's an F shape. So it can be upside down, it could be sideways. Some other F's that I see just off the top of my head, we can also go backwards here. So in this image, if I highlighted my transversal and went backwards with my F shape, I would have angle 3 and angle 7 as well. So that's another pair that you can write in there. Now we have same side interior angles. Now these are U angles. Another thing, it's not going to be a perfect U. It's going to be more like a hardly edged U. It's going to look more like that. So there are two different ways that you can draw this. And again, you guys want to get in the habit of highlighting these things so that you can see them more clearly. So here we have angles 4 and angle 6 are same side interior angles. And then separately, if we went the opposite way over here, we would have angle 3 and angle 5. So again, this transversal image is kind of nicely looking, but if your transversal is in a different direction, it might not look as clean and as nice as this, but the same properties would still apply. That's why it helps to use your highlighter to help you follow along. And it also helps to remember the letters here, so the Z's, the F's, and the U's. Now, this is something that's popping up that we've seen before, our vertical angles. So for this, you want to look for X's. So in this diagram, I see an X there, and then separately, I see an X over here, and you want to look at the angles that are opposite of each other. So here, we have angles 5 and 8 are vertical angles, angles 7 and 6 are vertical angles, and then separately, we have angles 1 and 4 are vertical angles, and we're running out of arcs here. We're going to do 4 for angle 3 and angle 2. So you want to get in the habit of looking for these in your diagrams. Again, they are freebies, and they help you build your story. Now, we have straight angles as well in this diagram, so you just want to look for your straight lines. I'm going to highlight a few. So I see a straight line here, which means that if I do angle 1 plus angle 2, I'm going to get 180. and then I see another one. You can go horizontally or you can go slanted here. Now with this one, I see angle 8 plus angle 6 has to equal 180. And then you can go on the other side of this as well. So on this side of my straight line, angle 7 and angle 5 are going to add to 180. And then I should have did the same thing here, but for this you can see angle 3 plus angle 4 equals 180 as well. So you want to get in the habit of looking for these, highlighting them so that you can build your story. Now, the last thing I'll say is that you might see more complex diagrams, but the same properties still apply. So you might have parallel lines with two transversals, more parallel lines cut by a transversal, or you might have intersecting transversals where you might see an image where we have a triangle here. So you guys will experience this in your task cards. Again, the same properties apply. Use your highlighters, use your pens. So for an example, if we're looking at this middle column here, if you want to identify your alternate interior angles, let's say we have line L, M, and N. If you wanted to identify your alternate interior angles just between lines L and N, when you're making your Z, you just need to include lines L and N. So for example, if I wanted my alternate interior angles, I would make sure my Z is touching line L, right? Go all the way down my transversal and make sure the other side of the Z is touching line N. Now this would help me. I'm looking at my inner corners of my Z, right? So this stuff in the middle, we could kind of pretend like it's not there for the sake. But if you were looking for your alternate interior angles between lines L and M, one side of your Z would touch L, one side of your Z would touch M, and then you would look at your inner corners. So again, when you have complex diagrams, you want to just utilize what you need, and then you could pretend like the other stuff is not there.